Our Prehistory is 100% listener funded, so please consider becoming a patron of the show. For $3 a month, you gain access to exclusive episodes, maps, and timelines. Your support is very much appreciated and allows this exploration of prehistory to continue. To become a patron, click on the link in the description of this episode, or go to patreon.com/ourprehistory. You can also help out the show by rating and reviewing it on your podcasting app and following us on Twitter and Instagram. The handle is @ourprehistory. A woman and her young daughter walked quietly through a lush green forest. Stepping gently over brown leaf litter, they were careful not to rustle a single leaf. The girl followed closely behind, imitating her mother's movements. In her left hand, the woman carried a bow of gently curving brown wood. In her right hand, she held a single arrow, tipped with a sharp white bone. Extra arrows and a pouch of tiny stone flakes hung behind her back. The girl was just old enough to accompany her mother on hunts, but her job was to carry a basket, woven from palm leaves, in which she gathered nuts from the forest floor. Suddenly, the woman stopped dead in her tracks. She'd heard movement in the trees above. So had her daughter, whose eyes were wide. Taking a slow step to her right, the woman slid the arrow into the string of the bow, pulled it back, and aimed straight up into the canopy of the forest. Her movements were steady yet powerful, those of a seasoned archer. After a deep breath, the arrow whizzed upward, followed by the predictable shriek and thump as a monkey fell to the ground. She pulled the arrow out of its chest, inspected it, and saw that the point had cracked. The morning was still young and unbroken arrows were left, so she'd try for more kills before returning to camp. Tying the dead monkey over her back and picking up her bow, she continued stalking deeper into the forest. This woman and girl lived in Sri Lanka 48,000 years ago. Her people were the first Homo sapiens to inhabit the tropical rainforests of South Asia. Bow hunting was a key technological innovation that allowed her to subsist in this challenging environment. Welcome to Our Prehistory, Episode 10, Out of Africa, Part 3. Around 60,000 years ago, a group of about 2,000 people moved from Africa into Southwest Asia and encountered Neanderthals. Within a few thousand years, this population of Homo sapiens began growing and expanding in many directions. Early dispersals into Europe and Northern Asia carried the Upper Paleolithic package of stone blades, bone tools, and personal ornaments. These types of objects would be components of cultures in this part of the world for hundreds of generations. Today, we complete our series of episodes about the out-of-Africa migrations, as Homo sapiens colonizes the vast majority of Asia and Oceania. Specifically, we will follow the path of hunter-gatherers who migrated east through tropical Asia into ecosystems governed by a warm, wet climate. The strategies they developed to survive were different than those of people who went into colder latitudes. But much like the Northerners, the customs adopted by people arriving in Southern Asia and Oceania set the template for hunter-gatherer life in these regions for tens of thousands of years. To start this journey, we have to go back to Southwest Asia, where the earliest out-of-Africa population became established. Groups of Homo sapiens probably living in the Levant or Zagros Mountains interbred with Neanderthals about 55,000 years ago. Soon after that event, a period of rapid dispersal began. Some groups of Homo sapiens dispersed eastward toward the Indian subcontinent, carrying with them Neanderthal DNA. These eastbound migrants were the founders of a genetic lineage known as Eastern Eurasians. Their descendants live in China, Japan, Vietnam, Indonesia, New Guinea, and many other surrounding countries. Another non-African genetic lineage, the Western Eurasians, was founded by the people who stayed behind in Southwest Asia. Descendants of Western Eurasians live in Europe and the Middle East. People representing mixtures of Eastern and Western lineages are found in Southern and Northern Asia, including in India and Siberia. Interestingly, Native Americans are also a mixture of Western and Eastern Eurasian ancestries because they descended from people who once lived in Siberia. The migration by Eastern Eurasians occurred quickly. They reached New Guinea and Australia around 50,000 years ago, where stone tools at several locations mark the arrival of our species. This means that Homo sapiens expanded over an immense distance in a short amount of time, across 10,000 kilometers from the Middle East to Australia in less than 5,000 years. Given the obstacles facing them, the pace of this dispersal by people with simple technology is remarkable. Dispersing through southern Asia, foragers moved into various tropical environments, including open grasslands, dense rainforests, swamps, cool montane forests, and seasonally dry woodlands. In each habitat, they had to discover uses for local plant species, which were edible, toxic, medicinal, or sources of useful fibers, along with the behavior of local fauna, which animals were dangerous, and what were the best strategies for hunting local prey. This knowledge required multiple generations of trial and error to acquire. This period of adaptation sometimes required the development of new methods of using stone tools to exploit the local resources. Also, along this route, Eastern Eurasians encountered other hominid species multiple times, possibly impeding their movement. The speed of this migration left its mark in the DNA of living people. Many genetic lineages found in populations of Europeans, Asians, and Oceanians split apart from each other over a very short period of time between 52,000 and 47,000 years ago. This means that over the course of about 5,000 years, non-Africans went from being a small, unified population to many much more widespread groups. This pattern is consistent with a very rapid expansion across Eurasia. Another pattern seen in the DNA of non-Africans is that genetic variation decreases the further one goes from Africa. For example, people in the Middle East have higher genetic diversity than those in India or Europe, who themselves have more genetic variation than East Asians and Aboriginal Australians. Native Americans have the lowest genetic diversity of all, meaning that there are fewer differences between the DNA sequences of Native Americans than between individuals in any other region. This pattern is another result of the rapid dispersal across Eurasia, because, for example, the people who moved into the Indian subcontinent, the founders of the Eastern Eurasians, were only a subset of those living in Southwest Asia, and only carried with them a portion of the genetic variation brought by the initial out-of-Africa migration. In genetics, this is called a bottleneck, or founder effect. The dispersal across Eurasia resulted in a series of genetic bottlenecks, as small groups continue to break off and disperse further from Africa. The groups of people who eventually reached East Asia, New Guinea, and Australia carried less genetic diversity than the bands who crossed the Sinai or Bab al-Mandab. One explanation for the speed of migrations to Australia is called the Southern Route Theory. According to this hypothesis, a southern route across the Bab al-Mandab Strait and along the coast of the Indian Ocean was taken by our species thousands of years before the northward migrations into Europe and Siberia. Under this theory, the pace of migration is explained by a lifestyle adapted to the coast and dependent on marine food. Staying near the ocean might have allowed people to bypass difficult terrain further inland, and the use of rafts or canoes could have increased the distances over which people could move by hopping from beach to beach. However, there's little archaeological evidence of coastal adaptations or migrations in southern Asia, and so there's no consensus about whether Eastern Eurasians first arrived along the ocean or further inland. Another theory is that Homo sapiens dispersed eastward through southern Asia multiple times, including before 60,000 years ago. This is based on a few fossils and stone tools in the Far East, including a jawbone and skull from Zhiren and Liujiang caves in China, dated to 110 and 68,000 years ago, teeth from Sumatra, Indonesia, dated to 68,000 years ago, and stone tools from one site in Australia, dated to 65,000 years ago. All of these discoveries seem to indicate that Homo sapiens reached Eastern Asia and Australia well before 50,000 years ago, which would contradict the conventional out of Africa story. There are two ways of explaining these discoveries that are consistent with the current genetic evidence. First, these artifacts could be incorrectly dated. Some archaeologists have questioned their accuracy due to technical aspects of the sediment layers in which the fossils and tools were found. In fact, some similar fossils from East Asia have previously been shown to be much younger than initially reported. The second possibility is that groups of Homo sapiens did arrive in East Asia before 70,000 years ago during the last interglacial, but left no descendants and so are genetically invisible in the DNA of modern people. This could have happened if the early populations of Homo sapiens in the East had disappeared or were very small when new migrants arrived 50,000 years ago. A catastrophic decline of human populations in the region could have been caused by the eruption of Toba volcano in Indonesia 74,000 years ago, the largest volcanic eruption of the past 100,000 years. The severe short-term impact on the climate due to the enormous quantities of ash and gas emitted into the atmosphere altered the ecosystems on which humans would have depended. Whether or not our species lived in East Asia before the Toba eruption, there's no question that people dispersed rapidly 50,000 years ago. To better understand the human dimensions of these migrations, I'd like to zoom in to the bands of people at the frontier. What incentivized hunter-gatherers to migrate long distances? Movement was fundamental to their life. Every few days or weeks, foragers picked up and left to a new campsite to avoid depleting plant and animal food. But this is not the same as migration into unfamiliar territory. The survival of foragers depended on their knowledge of the location and seasonal availability of food, and migration into an unknown landscape required more time searching for food and a greater risk of starvation, especially if they moved into an ecosystem with unfamiliar plant and animal species. Despite the risks of migration, foragers consistently and quickly expanded across Eurasia. To move from Southwest Asia to Australia in 5,000 years, each generation of people on the frontier had to move on average about 50 kilometers. This might not sound like a lot. A person could walk that distance in a few days, and much further in a lifetime. But a temporary voyage by one person is not the same as permanent survival and colonization by whole bands. Establishing viable populations in new locations requires the movement of hundreds of people to prevent inbreeding. So what allowed bands on the frontier to consistently take the risk inherent in migration? First, our species must have had a natural desire to explore, constantly sending parties to scout beyond their typical range, finding locations of valuable resources, and expanding their mental maps of their surroundings. Second, strong social networks with other bands would have allowed them to share this information and grow their collective memory. Being informed reduced the risk of failure when migrating. Wider relationships with other bands were also valuable for finding mates and preventing inbreeding. Third, population growth must have been consistently high during this period of expansion. More people within a given area meant food was harder to find, and pushed groups to set up camp beyond the frontier in unoccupied land. Under a growing population, the risk of migrating was outweighed by the need for unimpeded access to resources away from other bands. Based on anthropological studies of modern foragers, when bands exceed about 25 people, it's common for some members to break off and form their own unit of foragers. New bands would have looked for their own lands in which to forage and hunt. Rapid growth in groups of adventurous foragers with wide networks of social relationships defined Eurasian prehistory 50,000 years ago. Now that we have some sense for when and why humans dispersed across Eurasia, let's follow these pioneers as they ventured ever farther from Africa. The earliest archaeological evidence for the presence of our species in each region reveals that a wide diversity of customs developed quickly. East of the Arabian Peninsula, there's little evidence for the movement of Homo sapiens across the Iranian plateau or along the coast of the Arabian Sea. But people must have spent several generations traveling and living in this dry region before arriving in the more humid Indian subcontinent, covered at that time by tropical savannas and forests. The oldest fossils of Homo sapiens discovered in this region are from Sri Lanka, at the southern tip of India, but are quite young, only 35,000 years old. However, the stone tool record of South Asia suggests that the arrival of Homo sapiens came much earlier. A few episodes ago, we learned that 80,000 years ago, prepared core tools like those of the Middle Stone Age became common across large parts of India. But the identity of the hominin species that used prepared cores here is still a mystery. The next period of South Asian prehistory is much more closely linked to Homo sapiens. Around 48,000 years ago, another transition in stone tool technology began. Tiny stone tools, called microliths, appeared in central India and the island of Sri Lanka. In India, these microliths took the form of miniature blades, less than 4 centimeters long, 2 centimeters wide, and only a few millimeters thick. Sometimes they were specifically shaped into triangles, trapezoids, or crescent moons. The people of South Asia gradually adopted or spread these tools over the course of about 10,000 years, while older prepared core tools were abandoned. Microliths would become part of the toolkit of Homo sapiens in this region for tens of thousands of years. Based on the clear association between our species and these types of tools, it's very likely that Homo sapiens was present in South Asia by at least 48,000 years ago. The adoption of microliths was one of the most radical transformations in stone tool technology made by foragers. New techniques of stone knapping and different methods of constructing hafted tools came along with this innovation. The value of this change is evident from the repeated invention of microliths at different times and places across prehistory. We have already seen the appearance of small crescents in southern Africa during the Howissens port culture 65,000 years ago, and at the start of the late Stone Age of Eastern Africa 50,000 years ago. And as we continue to follow the development of human cultures around the world, microliths will pop up in other places too. So why did so many people independently decide that tiny tools were better than larger flakes. There were probably several advantages. First, they weighed much less than a Levallois point or a scraper, making them easier to transport in large quantities, an important factor for nomadic people who had to carry their possessions with them when moving to a new camp. Second, microliths were very thin, simplifying the attachment to a handle. They were inserted into narrow grooves carved into a wooden handle, with an adhesive substance added for binding. Third, multiple microliths could be combined in different configurations on handles. Foragers would have valued the versatility afforded by being able to craft different specialized tools from a single knapping technique. Knives, awls, and weapons for butchering, woodworking, hideworking, and plant processing, all made from microliths. Fourth, it did not require a high level of skill or experience to produce a large number of microliths of a standardized shape from a single core stone. This abundance made it cheap to replace broken microliths in hafted tools, extending their utility. Finally, microliths would have been desired by hunters who produced arrows, which required very small points. The use of microliths in daily life varied across prehistoric cultures, and in South Asia we find one application of these tiny tools by our species. In Sri Lanka, an island off the southern tip of India, excavations at Pha Hien Cave have one of the best preserved records of early human life in the region. When Homo sapiens first arrived, Sri Lanka was a peninsula attached to the Indian subcontinent and was covered by tropical forest. This was probably the first rainforest encountered by migrants into Eurasia. At Pha Hien, fossils of one adult woman and 3 children are 35,000 years old, the oldest known Homo sapiens in South Asia. But tools and animal bones show that this cave was occupied starting 48,000 years ago by people using microlithic stone tools. Amazingly, they survived in this rainforest by hunting monkeys and large tree squirrels. Bones of these animals were found in large numbers with cut and burn marks. Their primary hunting weapon was a bow and arrow, with points made from sharpened monkey bones. Microliths may have been attached as barbs to inflict greater damage to their prey. These foragers also collected nuts from large forest trees and palm fronds, which could have been used to make many items, including baskets. The lifeway adopted at Pha Hien was a radical divergence for hunter-gatherers that originated in Africa during the Middle Stone Age, where large game hunting in open grasslands dominated. The ability of people in Sri Lanka to hunt agile small animals demonstrates the capacity of these migrants to invent a new technology to access meat, without which survival would have been nearly impossible. A portion of the people living in the Indian subcontinent continued moving eastward, south of the Himalayan mountains into Southeast Asia. Once again, limited fossil remains make it difficult to track the movement of these migrants, but genetics reveal one key event during this portion of the eastward dispersal. Homo sapiens met Denisovans, possibly for the first time. No Denisovan fossils have been discovered in southern Asia, but we know that they were there because Homo sapiens who migrated through South Asia interbred with this hominin species. Denisovan genes that originated in this mixture are found in all people descended from these migrants. For example, in people from India, China, Indonesia, and Native Americans, about 0.5% of their DNA is Denisovan. This hominin was an evolutionary cousin of ours, related to Neanderthals, whose fossils have so far only been discovered in Siberia and Tibet, but who must have lived in parts of South Asia as well. There's very little that we can say about our encounter with Denisovans. Whether they were an impediment to the dispersal of Homo sapiens and how the expansion of our species contributed to their extinction is unknown. Much like the mixing with Neanderthals, Denisovan DNA contained beneficial and harmful genes to our species. Among the advantageous traits were immunities to local diseases, which many people still possess today. As much as we don't know about Denisovans, they must have been quite like us, similar enough biologically to procreate with migrant Homo sapiens. Another consequence of the migration into Southeast Asia was a cultural transformation that shaped forager life for generations to come. Here, in terrain dominated by tropical forest, people abandoned the use of prepared cores that had been made by our species for hundreds of thousands of years. They did not replace them with blades or microliths like people entering the Levant, Europe, Siberia, and India. Instead, bands of Homo sapiens embraced simpler stone implements. Referred to as cobble tools, they were crafted from rounded stones found in rivers. To make tools from cobbles, they struck them with another stone to remove a few irregular flakes. The sharp edges on the cobble and flakes could both be used. Heavy cobbles with sharp edges are called choppers and are relatively large, often longer than 10 centimeters. The production of cobble tools is much less sophisticated than prepared core tools. It requires fewer steps, less technical skill, and less planning. Prepared cores allowed greater control of the thickness and shape of the resulting flake. In fact, cobble tools go back more than 2 million years and were used by Homo habilis, a predecessor to larger-brained hominins. Cobble tools would continue to be used in Southeast Asia for tens of thousands of years after the arrival of Homo sapiens. This appears to be a fascinating case of technological regression by our species, from more advanced tools to simpler ones. So what happened? Did people forget how to make prepared cores? It's possible. In small groups dispersing into new parts of the world, certain skills or knowledge could be lost. But the more likely explanation is that humans arriving in Southeast Asia decided that they didn't need complex methods of stone tool making. In fact, this might not have been a technological regression at all, but a shift away from a dependence on stone towards greater use of organic materials. The tropical forest of this region provided very unique plants, specifically large amounts of bamboo and rattan. The wood and fiber from these plants is extremely versatile. For example, a strip of bamboo wood can be made into a knife or a point, sharp enough to cut meat. This set of facts has led to the bamboo hypothesis, which proposes that heavy cobble choppers and irregular flakes were mostly used to cut and shape bamboo and rattan into various tools and containers. So far, no direct evidence of bamboo tools have been discovered, and it's unclear what benefits these tools provide over stone. But if the bamboo hypothesis is correct, cobble tools are a visible sign of a plant-based technology developed to exploit an especially effective resource. The idea that cobble tools were an adaptation to local conditions is supported by the prehistory before the arrivals of Homo sapiens. For hundreds of thousands of years, Homo erectus and probably Denisovans made cobble tools in Southeast Asia. Homo sapiens migrants were actually perpetuating a regional tradition. They may have even learned about the benefits of bamboo tools from Denisovans. Unlike other parts of Eurasia, the replacement of local hominin species by Homo sapiens in Southeast Asia was not accompanied by a major change in stone tools. After the adoption of cobble tools, a major split in the Eurasian lineage took place. Some Homo sapiens groups went northward into temperate climates of China, while others moved southward into tropical Southeast Asia. This divergence created two distinct genetic lineages that can still be seen in the DNA sequences of people living today across East Asia and Oceania. Although these groups remained isolated for thousands of years, they both carried the legacy of this eastern dispersal, Denisovan DNA and simple cobble tools. The human bands that went south colonized a Southeast Asian peninsula much larger than today's. Low sea levels connected many of the islands of Indonesia and Malaysia to the mainland, including Sumatra, Java, and Borneo. This formed a large landmass called Sunda. Sunda was covered mostly by tropical forests, but during drier ice ages, the interior of this peninsula was transformed to grassland. An open corridor of this ecosystem may have facilitated a migration southward for our species. 2 skulls of these initial colonizers have been discovered, one in Laos from 46,000 years ago, and another in Borneo from 37,000 years ago. Today, the direct descendants of these original colonizers still live in isolated parts of Southeast Asia, including the Philippines, Malaysia, and the Andaman Islands. These ethnic groups have been collectively referred to as negritos due to the dark pigmentation of their skin. Several have maintained a hunter-gatherer life and unique languages much different from those of other ethnic groups in the region. One archaeological site in particular has retained detailed evidence of the life of migrants into this region. At Naya Cave near the northern coast of Borneo, where one of the earliest Homo sapiens fossils was found, human habitation extends back to 46,000 years ago. Foragers here made simple stone flakes from cobbles. They hunted monitor lizards, bearded pigs, monkeys, turtles, and orangutans, and caught large catfish and carp in nearby rivers. We don't know what hunting and fishing strategies these people used, but bows and arrows or traps are likely. A variety of plant remains are found at Naya, including yams, taro, nuts, and heart of sago palm. Some of these are poisonous, but early inhabitants of Sunda had developed methods of neutralizing the toxins before consuming them. Several small pits made by these people have been discovered, where they buried nuts to leach out the hydrocyanic acid contained within. Eventually, migrants in Southeast Asia reached the end of the Sunda Peninsula. But the ocean did not stop the dispersals of our species. Instead, they adapted once again, this time to coastal and island life. Looking out at the horizon from Sunda, foragers would have been able to see islands. To the north, the Philippine archipelago, and to the east, the islands of Wallacea, which laid between Sunda and New Guinea. Some groups of Homo sapiens became proficient island hoppers, crossing the small gaps between these islands. The earliest Homo sapiens fossils in Wallacea is a tooth from Timor, 42,000 years old, but archaeological evidence from several islands goes back to 46,000 years ago. They must have made these crossings with either rafts or canoes and paddles. Most of these short crossings only took them about a day. Not only did they develop skills in seafaring, but they began depending more on resources provided from the ocean. At one site in Timor, occupied 42,000 years ago, people primarily ate seafood, including crabs, shellfish, sea urchins, and even large quantities of tuna. On some of these small islands, early colonizers had to depend on hunting much smaller animals, including pigeon, duck, bat, turtle, and rat. Interestingly, on the largest Wallacean island of Sulawesi, early Homo sapiens colonizers hunted a larger animal, the Sulawesi warty pig. In a prehistoric first, evidence for hunting does not come from leftover animal bones, but from paintings of hunting scenes drawn on several cave walls on the island. These are the oldest documented cave paintings attributed to Homo sapiens. Several were painted more than 40,000 years ago, including red and purple ochre, but the oldest is more than 45,000 years old. They include human stick figures holding spears and hunting pigs and dwarf buffalo. These paintings were large murals up to 4 meters wide. Comparisons of several paintings reveal a local artistic tradition of repeated motifs and techniques. For example, warty pigs and stencil handprints were common elements, and animals were drawn in profile with dashed lines and points used to shade in the bodies. The role of art in hunter-gatherer societies is a topic that I look forward to exploring more in future episodes. Sulawesi holds the earliest evidence of a significant advancement in the complexity of symbolic expression. The appearance of representational art, which are depictions of things observed in life, goes beyond the simple geometric designs previously made by our species. Although the capacity for representational art probably appeared much sooner, by 45,000 years ago in Southeast Asia, Homo sapiens was using that ability to convey narratives. The stories told by paintings in Sulawesi reinforced common experiences, or even mythology, a powerful instrument for shaping social structures. As Homo sapiens spread into Sunda, Wallacea, and the Philippines, they were not expanding into unoccupied lands. The tropical forests and grasslands of Southeast Asia were home to at least 3 other hominin species. One of these was Denisovans. Somewhere in Sunda, Homo sapiens migrants once again encountered these hominins and interbred with them. Again, no fossils of the species have been discovered here, but the DNA of modern people shows that there was a second episode of mixing between Homo sapiens and Denisovans. Descendants of the original migrants into this region, living today in New Guinea, Australia, and parts of Southeast Asia, possess additional portions of Denisovan DNA that did not originate from the first interbreeding event further northward. In fact, New Guineans and Aboriginal Australians have the highest level of Denisovan ancestry of any modern people, 5% of their genome. Some of their Denisovan genes come from the initial interbreeding in South Asia and are shared with other Asians, whereas other Denisovan genes come from the second interbreeding in Sunda and are only found in New Guineans and Aboriginal Australians. The other 2 hominins were dwarf species, living on islands, and their fossils have only recently been discovered. First, Homo floresiensis lived on Flores Island in the Wallacean archipelago, today part of Indonesia. Second, Homo luzonensis lived on the island of Luzon, today part of the Philippines. Both of these species are only known from fossils at single sites. They probably evolved from Homo erectus, the first human species to reach Southeast Asia. Isolated from these islands, which were always separated from Sunda, they evolved to be shorter than Homo erectus, with Homo floresiensis standing 106 centimeters tall and Homo luzonensis slightly taller at 120 centimeters. That's only about 3.5 feet. Their small size may have been an adaptation to the lack of food resources on these islands. Homo floresiensis made stone tools and hunted pygmy elephants and rodents. These small people have been nicknamed hobbits. Both floresiensis and luzonensis lived until about 50,000 years ago, when Homo sapiens arrived in the region. There's no genetic evidence in living humans of interbreeding with either one, but a strong possibility is that competition from our species led to the extinction of these small people. The presence of these tiny humans in tropical forests may sound like something from a fantasy novel, but it was a prehistoric reality. The next step in the dispersal of our species was a major sea crossing from Wallacea to Sahul. Sahul is the name of the continent formed from the unification of New Guinea and Australia during low sea levels. The rapid colonization of Sahul is one of the greatest achievements of our species as part of the expansion out of Africa. No evidence exists that any other hominin species ever made this voyage. It's unclear from which Wallacean island the settlers of Sahul departed, and whether they first arrived in New Guinea or Australia. The shortest crossing would have been to New Guinea, where the shore was visible from some Wallaceian islands. This crossing was about 80 kilometers across water that connected the Indian and Pacific Oceans, and as a result had very strong currents. Wallaceans must have become competent ocean navigators. The crossing to New Guinea would have taken about 3 days, paddling a raft or canoe against the direction of ocean currents. It's estimated that at least 500 people colonized Sahul from Wallacea, based on the genetic diversity of New Guineans and Aboriginal Australians. Many rafts of people made the trip as part of planned and provisioned excursions. Return trips back to Wallacea likely informed those left behind of what the initial explorers found, encouraging more to follow. Once they arrived, the first Sahulians expanded quickly across the continent. As I mentioned earlier, stone tools first appear in both New Guinea and Australia around 50,000 years ago, and by 45,000 years ago, foragers occupied vast areas of this continent, from the northern coast of New Guinea to the far western and southern parts of Australia. The oldest human fossils from Sahul are 40,000 years old, from the southern interior of the continent. The bones of 2 individuals were partially buried and covered with red ochre powder, suggesting some kind of funerary ritual. The colonists of Sahul encountered a flora and fauna with which they would not have been familiar. Large marsupials roamed the continent, including short-faced kangaroos, the dog-like Tasmanian tiger, giant wombats, and the hippo-sized diprotodon. On the north coast of New Guinea, covered by tropical forest, early inhabitants hunted wallaby and arboreal marsupials. By 49,000 years ago, people had climbed into the highlands of New Guinea and were using large cobbles to make axes. They foraged for nuts and yams, which they had brought with them from the lowlands. Transporting yams may have been an intentional effort to extend the range of a valuable plant. In both New Guinea and Borneo, the arrival of Homo sapiens coincides with an increase of charcoal in sediment records. Humans may have intentionally started fires to open up forests and encourage the growth of their preferred foods. Although these examples are far from plant domestication, it seems that the earliest occupants of the tropics sought to shape nature to their benefit. The impressive expansion into Sahul marked the end of the dispersal of our species eastward. Well, for the most part anyways. People did reach Tasmania around 38,000 years ago, which at the time was connected to the southern coast of Sahul. And around 46,000 years ago, maritime travelers colonized the Bismarck Archipelago, 50 kilometers northeast of New Guinea. And finally, 34,000 years ago, people crossed 150 kilometers of open ocean to reach the Solomon Islands. But this was the limit of the seafaring capabilities of the first Oceanians. It would require a whole other group of people, thousands of years later, for Homo sapiens to colonize the much more distant islands of the South Pacific. To finish today's episode, I'd like to follow the branch of Eastern Eurasians who went north. Like those who entered Sunda, these migrants carried simple cobble tools into China. When they reached the Yellow River of North China, people stopped using heavy choppers but retained the tradition of small irregular flakes. It's difficult to identify the arrival of Homo sapiens in East Asia based on stone tools, because these simple flakes lack features to distinguish them from those used by the previous hominin inhabitants of the region. The earliest undisputed Homo sapiens fossil in East Asia is the Tianwan skeleton found near Beijing. It's 40,000 years old and provided the oldest DNA from the Eastern Eurasian lineage. The genome of this individual revealed him to be closely related to people living today in East Asia, suggesting a relatively stable population in this region for tens of thousands of years. In northern China, people migrating from the south met groups coming from Siberia, who carried with them the Upper Paleolithic package of blades, bone tools, and ornaments. These two branches of the out-of-Africa migration had been separated for thousands of years before meeting again south of the Gobi Desert. Over time, their spoken languages had evolved to the point of mutual unintelligibility. But the differences between these groups did not prevent large-scale mixing between them over time. A person living in Mongolia 35,000 years ago is proof of this, possessing 75% ancestry from the Eastern Eurasian lineage, similar to the Tianwan individual, and the rest from Siberians. With Homo sapiens in East Asia by 40,000 years ago, only the most forbidding and remote parts of Eurasia were left to be colonized. First, the Japanese islands were colonized 38,000 years ago, attested to by the widespread appearance of stone tools. Much like Sahul, the dispersal to Japan required significant ocean crossings, totaling about 70 kilometers. Even more impressively, the small Ryukyu Islands south of Japan, isolated by 150 kilometers of open ocean, were reached 36,000 years ago. Much like in Wallacea, people had developed highly skilled maritime navigation. Next, the high elevations of the Tibetan Plateau seem to have posed a special challenge to our species and were not colonized until 30,000 years ago. Around that same time, Homo sapiens expanded into the extreme cold of the far north of the continent, beyond the Arctic Circle. At that point, 30,000 years ago, only America and the islands of the Pacific remained unoccupied. The expansion of our species between 60,000 and 40,000 years ago reveals qualities of Homo sapiens that may have set us apart from other hominins. These migrations demonstrate the ecological flexibility of the foragers leaving Africa, spreading from arid grasslands to cold mammoth steppe, hot tropical forests, and distant islands. Some specific moments of technological ingenuity pierce through the veil of prehistory, such as bows, needles, and blades. Innovative tools help explain the adaptiveness of these migrants, but the speed with which they dispersed would not have been possible without strong networks of communication and cooperation between forager bands. They maintained social connections with symbolic objects like jewelry and painted murals. In some parts of Eurasia, long-lasting traditions were established by original settlers. The dispersals across Eurasia created regional differentiations in customs that remained for tens of thousands of years. Although we might celebrate this expansion as an achievement of our species, we should keep in mind that there's a dark side to the out-of-Africa migrations. This expansion of Homo sapiens was an apocalypse for 4 other hominins. The correlation between the appearance of our species and the catastrophic collapse of others suggests that we played some part in their extinction. The exact role we played in their demise is unclear, but it seems unlikely that we were always peaceful colonizers. In our next episode, we will begin exploring the cultures that developed in Europe as Homo sapiens replaced Neanderthals. If you've enjoyed this episode, please consider visiting this podcast's Patreon page and becoming a contributor so that I can continue bringing you our prehistory.